Okay, so the way Unix access control policies are implemented, that it's essentially based on the DAC, that is a discretionary access policy control policies, and it has certain limitations, right? So one of the first limitations is the fact that the root is super powerful, and it's been designed in a way, in that way the root can kind of uh, change permissions of any file. It can delete or modify any file, right? And the problem does come when the root user itself is untrusted, or if the root user or root login is essentially compromised, right? Now when this happens, your it or your root the root login itself is compromised, it essentially would mean that every user or every file present in that system is also compromised. Okay. The second problem with Unix access control policies in Linux, or the Unix access control policies, is that it is very coarse grained, right? So every user is assigned a UID, and it is just this UID or user ID and the group ID which kind of controls everything. So it's the UID is kind of a decider whether a file should be given access to something or not. So because of this, um, uh, it is difficult to essentially obtain more intricate access control policies. For example, a user X wants to run a program Y to write to file Z, and then we want that X, Y, and Z are essentially owned by different users, and they are in different groups. So with the current mode of operation, the current design, obtaining or achieving this is not that straightforward. Okay. The next problem with having such coarse-grained permissions with the help of UID is that a user cannot essentially defend itself against allegations, right? So let us say that the user is, say, uh, browsing the internet and happens to essentially by mistake download a particular malware or a malicious program, and this program essentially executes. So when this program executes, it executes with the privileges of the user itself. So in other words, it executes with the UID of that particular user. Now any damage that this malware does, for example, if it encrypts all the files that are present or that are accessible, it's very difficult for the user to be able to defend itself against this fact, because the malware was essentially run with the executed with the UID of the user, right? A third limitation is that only one user and one group can be specified for a file. So another drawback of the discretionary access policy is that it is not concerned with information flow. It is rather its main concern is about who or what subjects can access a particular object. It is not really concerned about the information that is present in that particular object, right? So due to this drawback of discretionary access, and therefore the way Linux or Unix based access control policies work, such a thing is essentially possible, right? So we have a document which is, say, owned by a particular user, and this user has given read access to another user, maybe because they are in the same group. Now, but wants to prevent a third user from accessing that document. So we have these three users and one document, right? And this document is created and owned by user 1. It can be read by user 2 and not accessible to user 3. Now, if the second user is essentially malicious, the user can essentially create a new document and copy the contents of the original document A into the new document, right? And then grant permission to the user 3 to access this new document. So this way, even though the original file was not accessible by the third user, the contents of that document or the information of that particular document is now available to the third user. So an enhanced methodology, rather than using discretionary access policies, is to use information flow policies, where the concern is not just about the about specific objects and who can access those objects, but also the concern is that information present in those objects should be restricted to authorized parties or authorized subjects, right? So one very popular information flow policy is the mandatory access control, and the form of multi-level security or MLS security is something which is essentially very common, right, or much studied about. Here, just like previously in the discretionary access control, we also have subjects and objects. Now, unlike the discretionary access policies where we had subjects and they are given permissions for specific objects, here we have different levels. So specifically, for instance, we have 4 different levels: top secret, secret, confidential, and unclassified, right? With top secret being the most privileged and unclassified being the least privileged. So every object in the MLS policy or MLS kind of a system is essentially given a classification level. So it means that if I create an object, for instance, a particular file, I would assign it a particular classification level. For instance, I would give the object, let us say, a secret classification, right? And every subject is given a clearance level. So every process or every application or every user is given one of the 4 clearance levels. So I could have a user who is, say, having a clearance level of confidential, secret, top secret, or unclassified. Okay. So now, based on the classification level and the clearance level, one can dictate or mediate how information or flows from one level to another. So, for instance, a subject with clearance X can access all objects in the clearance in the classification level X and below X, but not vice versa. So, what do I mean by this, right? So, suppose I have a subject or a particular user with a clearance of secret, right? So, this means that this particular user can access all the documents in the level of secret, confidential, and unclassified, but cannot access any document in the top secret level, right? So, here we are more concerned about the levels that and where the objects are present and how information flows across these various levels. Then, based on these different levels and okay, so based on these different classification level and clearance level, one can essentially define different access policies, right? So one well-known policy is the Bella-Padula model. It was developed in 1974, and the objective of this is to essentially ensure the confidentiality of information. So ensures that the information does not flow to those levels which are not cleared. Okay, so the objective is that the information does not flow to those that are not cleared for that particular level. Okay, so so the Bella-Padula essentially suggests 3 properties. It suggests no read up or the simple security property. There is a no write down property or the star property, and the DS property, which is essentially your discretionary security property. So the DS property is what we've essentially studied in the earlier. This corresponds to something similar to the access matrix, and the cell corresponding to a particular user and a particular object decides whether that object can be essentially accessed or not. The no read up and no write down, which we will essentially explain in the forthcoming slides, are more concerned with the flow of information. Okay. So what do we mean by no read up? So suppose we have a particular user with a clearance of confidential. So it means that this particular user cannot read secret and top secret documents, but has access to confidential and unclassified documents, right? So this way, the user can only has access to information which is at its own level or below that level. Now, the second property of Bella-Padula is no write down. So no write down essentially means that a particular user can essentially modify documents which are marked confidential, secret or top secret, but cannot essentially modify unclassified documents, right? Or rather, um, the user cannot essentially write down or modify or change an unclassified document. So this no write down property essentially prevents Trojans. So what is a Trojan and how essentially is no write down property essentially prevented? So a Trojan is essentially a malicious part of code which runs with the privileges or executes with the privilege of a particular user. So for example, let us say there is a program which is uh, uh, present, which has confidential clearance, and it is essentially executed by a user with a confidential clearance, and this particular program or application is affected by a Trojan. So when the Trojan executes, the Trojan also executes with the what with the clearance of confidential. Now, if a write down is permitted, then it would mean that this particular Trojan can read the contents of the objects present in the confidential level and write the contents down to unclassified. So, which means that there would be a flow of information which is from confidential to unclassified, right? And this is not what Bella-Padula supports. Bella-Padula essentially says that the flow of information can be only upwards, that is from unclassified towards top secret, and not vice versa. So with the help of no write down, one can prevent such cases where a Trojan or any other malicious user is moving the information from a particular level to a level which is lower than itself. Yeah. So we also have the third property, which is the discretionary access property or the control, and this is essentially fundamental. So it essentially says that an individual may grant access to a document he or she owns to another individual. However, the MAC rules must be met. So MAC rules override any discretionary access control. A user cannot give away data to unauthorized persons, right? So one of the limitations of the Bella-Padula model, as one would expect, is that write up is possible, right? So for instance, someone with the clearance of confidential could possibly write or modify a document in secret or top secret, and this is permitted because the Bella-Padula does not deal with the integrity issues. It would take the help of the discretionary access policies to ensure that such unauthorized modifications of documents at a higher level is not permitted, right? So there are a lot of yeah, as we've discussed, every user or every subject using this particular BLP model or these multi-level level security model, MLS model, would essentially have a certain level of classification. So what happens if this particular clearance level essentially changes? So what happens, for instance, if somebody who has a clearance level of secret or top secret gets now changes to a clearance of unclassified? For instance, this could be possible if let's say this particular user leaves the company and then he goes from a top secret or a secret or a confidential user to an unclassified user. So such kind of situations are not easily handled by the Bella-Padula model. So there is a concept of tranquility, and which creates or makes some certain assumptions and certain creates some certain properties to handle such situations. So one is the strong tranquility property, which says that even if a subject leaves an organization, for instance, a user leaves an organization, it still maintains the same level of clearance. So in other words, subjects and objects do not ever change the label during the entire lifetime of the system. So a user who has a clearance of say secret or top secret would always have that same level of clearance. Now, this is very difficult to achieve in practice. Now, there is an alternate property called the weak tranquility property, where subjects and objects do not change label in a way that violates the spirit of the security policy. So, what we mean by this is that it is permitting change of clearance of a particular subject and a particular object from one level to another, but the fundamental requirements or the fundamental guarantees of BLP should be essentially satisfied.